Welcome to my channel, Richard Lloyd USA. I am Richard Lloyd. I'm a content producer here on YouTube. If this video helps you out and you like this video, do me a huge favor and click the like button on the bottom right hand corner over here and give me a big thumbs up. That helps my channel, it helps my video, and I greatly appreciate it. Also, in the comments section below, leave your comments, your questions, and anything else you wish to relate to me in that comment section below. I look at them regularly and respond to them regularly as well. Anytime during the process of watching this video, you can subscribe to my channel, and as part of the process of subscribing to my channel, you'll see a bell icon. If you click on the bell icon, every time that I put up a new video, you will be notified, and then you can watch it at your own leisure. Also, in the video description below, you'll see links to all the products and services that I show inside my video. Now, usually these are affiliate links, and what that means is that at no additional cost to you, I earn a small commission when you use them to click through and buy those products. So do me a huge favor and click on those links if you're going to go and buy the products that I've shown you. It helps my channel, it helps me, and it helps support me to make more videos like this for you in the future. So be sure to click on those links below in the video description. Also, as a benefit, you will be getting the products from the same sellers and the same sources as I got them, so you'll be sure to get the exact same product that you saw on the video as well. I want to thank you in advance for doing so. Today I'm going to be showing you the Linksys EA8300 AC2200 router. This is one of my favorite routers. It's neck and neck with my TP-Link AC1900 Archer C9, which I'll show you here. Both of these are available on Amazon, and I'll put links for them in the video description below for you. The AC1900 is a great router as well, but it's only a dual band, where this one is a tri-band. The only reason I like the AC1900 a little bit better, and it's just personal, it can use the DD-WRT third-party firmware. This one, the Linksys cannot, so it's kind of, you have to use the stock firmware with it. But there's nothing wrong with the stock firmware. It works really great, works really fast, and very happy with the performance on the Linksys. So today I'm going to show you how to port forward on that. Things I like about this router: gigabit Ethernet across all the ports, including the WAN port. It's got tri-band, which is something I'll explain to you here in a second. And it also has a USB 3 interface on the back, or port on the back, to allow you to plug in an external hard drive and share it out to the network, which is a really nice feature. And it's really fast across all the bands and across the network. This router really performs well, so I'm very happy with it. And it's neck and neck with the AC1900 as far as network performance goes, and it's slightly bit better on Wi-Fi because of the tri-band. And you can see here that they actually explain that the 2.2 gigabits go across the three bands. It's not across all the bands. So in other words, it's split between the three. And then they try to explain it over here, but they sort of mess it up. So I'll show you what the actual performance is here from the Linksys website. 400 megabits on the primary, 2.4 gigahertz max, 867 on band 2 and 867 on band 3. So all three put together give you the 2200. So not bad performance, actually really good performance, and I can recommend this strongly or well to anybody, because I know the router works really well. So if you're looking for a good middle range router, the EA8300 from Linksys is excellent. So next I'll show you the rules and some of the technical details you need to know to port forward, and then I'll show you how to port forward this router using the Linksys interface on the router itself, which is now slightly different than the legacy Linksys interface, but I'll show you how to do it and where to find the settings, and we'll go from there. Rule number one is all the things you're going to be port forwarding to on your network need to have a hard-coded IP address. In other words, you have to set the IP address manually on your devices so they don't change, because DHCP, if you have them to set automatically, the IP addresses will change from time to time, and then your port forwards will no longer work. There is a way of getting DHCP to assign them the same IP address every time, but I'm not going into that in this video. I'll go into it in a future video after I'm done doing all these port forwarding videos. And if you want to do it that way, you can do it that way. But the simplest right now is to statically assign an IP address to each one manually. So TCP is the internet protocol, and it has two different protocols that run inside it. Number one is TCP, that's hence TCP IP. TCP stands for Transmission Control Protocol, Internet Protocol / Internet Protocol. And there's another protocol called UDP. TCP, and I know this is technical, but you sort of need to know it because you're going to be forwarding for one or the other on these routers, okay? So basically, TCP is really reliable but slower. UDP is less reliable but much faster. So again, depending on what device you're forwarding to, you're going to have to either forward one or the other or both. So it's up to you to find out which one needs to be forwarded to what port. But I'm showing you this on this video. These ports are virtual ports. They're just something that is inside the packet that it plugs into the other device. So everything on a TCP/IP network connects to an IP address, and when you hit that IP address, it has to know which port it's going to connect to do a successful connection between the two devices. So that's what I'm showing here, how to port forward from your router to devices inside your network out to the real world. If you look at a PS4 and an Xbox, and I'll show you that next, but if you look at, for instance, a PS4 game unit, you need to forward all these ports from the outside world to it on the inside of your network. And you see here that I have 5 TCP ports that need to be shared out to the world, and 2 UDP ports. So there's why the TCP and UDP explanation is important, because certain devices use both. And so there's the port mapping for a PS4. Let's go over to the next one. The Xbox uses different ones, mostly different ones. 80 seems to be common. And TCP and UDP again. So these are the ports that you need to forward from the outside world to your Xbox for it to communicate successfully in the world. So again, why you need to know about port forwarding, because devices like this need it to happen. Here's the configuration of hardware that I'm going to set up for this video. I've got the main router connected to the internet, and that is the TP-Link Archer C9 on 192.168.0.1. Then I created an internal network for the Linksys router, and you can see here that it's on 192.168.1.1. So I've got one network, and then connected the second network to the primary network. The reason I did that is it's much easier to show you the port forwarding and testing through that Linksys router by just connecting to the main router, as opposed to going out into the internet and coming back. It's much simpler. And from that router, I'm going to be showing you the Raspberry Pi connected to it with ports 80, 88, and 22 shared out, and an IP webcam on port 8080 as well. And again, I'll expand on this a bit here on the next slide. Here's what we have, and just so you know, regardless of being inside or outside on the network, once you share out through the WAN port and you connect that to the internet, it's the same. It would work the same out on the internet. So it just makes it simpler for me and easier to show you when I test it how it's working. So here we're going to go to the inside of the router, and on the inside, being on the LAN side or the Wi-Fi side of the router, we're going to have the Raspberry Pi 3B Plus on 192.168.123 sharing out a web server through port 80. Kodi Media Remote and Kodi Media server is a media server running on this router, but it has a remote control that you can use through a web page, so it goes out on port 8080, and then SSH on port 22. That's the command line interface. That's how you connect to the Raspberry Pi and control it through the command line. So again, I'll show you all this as the video rolls on. Then I have a webcam broadcasting on port 8080 on 192.168.1.1. 192.168.1.110, and it's going to be going out on port 8080 as well. So here's what it's going to look like on the outside. To connect to the web server, we're going to use port 80, and that's standard. All web servers are actually on port 80. You just don't see it because the browser doesn't show you that it's connecting to it on port 80. But again, that's automatic, but I'll show you it anyway. So we're going to have a web browser on port 80. The port 9090 you notice here on the Kodi Media Server remote. The reason it's 9090, not 8080, is because you can't have two devices on the same port on the outside of your router. So because even if it was possible, though the router won't let you do it most times, even if you did do it, when something came to look at your 8080, it wouldn't know which port to go to, which device to go to. It would go, I got two, I don't know which one I'm going to go to. It doesn't know how to deal with that situation. So the way I did deal with the two 8080s on the inside is by taking the 9090, connecting it through to the 8080 on the Kodi Media remote, and on the 8080 on the IP webcam at the bottom, I just went straight through to it. And then port 22 on SSH is just straight through all the way to the Raspberry. And this may be a little confusing right now, but I'll show you it working, and you'll know and see and understand how it all works. And I did this 2 ports on 8080 on purpose to show you that you can handle that by changing the outside port, right? You can have multiple devices on the same port on the inside, but you can only have one device per port on the outside. So you need to change it up, and that's what I did here. So next, I'll show you what you need to know to log into your router and how to log into it. In order to log into the router, of course, you need to know what the IP address of the router is, and you may not know what your IP address for your router is, or you may want to verify it just to make sure, and I'll show you a quick trick to how to do that. So what you're going to do is go down to your taskbar down here to the bottom right, and you're going to choose or right click on your network icon. In my case, I'm connected through Wi-Fi. You may be hardwired, so the icon will look a little different, but regardless, right click that icon, choose Open, Network and Internet Settings. Then we're going to go to click on Network and Sharing Center. Then you're going to click on Change Adapter Settings. And here you'll see all your network adapters. In my case, I'm connected to Wi-Fi. Whichever way you're connected, it'll be pretty obvious. It'll have no red X in it, and just basically choose it by right-clicking it and then go to Status. Then under Status, you're going to go to Details. And in here, you'll see a bunch of numbers, but the one that matters is the default gateway. Usually, your default gateway is your router. In my case, it's the IPv4 default gateway is 192.168.1.1. So that's the number I need to know to get to my router. Whatever your number is, it may be different. That's the number that you use to get to your router. And I'll show you how to do that next. So let's close all these windows off here. And what you're going to do is open up a browser page or window, and then we're going to type the IP address that you just found in that last step. So in my case, it's 192.168.1.1. And we end up on the front page, as we should, on 192.168.1 of the router's access. So at this point, hopefully you're not using the default password on your router. If you are, use it one more time to log in and change it. Do not leave the default password on your router. It makes it really easy to hack your router. So just change your password if it's already the default. The default on most Linksyses are admin for the username and admin for the password. This one doesn't have a username, so it only has a password. So in this case, it would be admin. And if you want to see how easy it is to find your default password, just do a Google search for Linksys EA8300 default password. And then let's just hit that again so it comes up. And you can see Linksys default password list. So this even tells you, change the default router password from admin to something more secure, right? So take the hint. Look at the list. It shows you every router, the IP address for every router, and the model number and the username and password. So that's how hard it is to find your password, your default password to your router. So please change it. So, security note, everybody should know, change your default passwords. So here I've already have changed it. So just logged in with whatever your password is. Now, if you don't know what your password is to log in, then more than likely you're going to have to reset your router. And please note that at that point, everything goes back to its defaults, including the default password, like in this case would be admin. And then you can log in and change it. But you will also lose all your configurations inside your router when you reset it back, because it goes back to the factory defaults. So, small word of warning on resetting your router. But if you want to know how all that is done, just go to the Linksys website for your router, or whichever router you're using, and go through their documentation on the router. It always shows you how to reset it. Okay, so here we're going to hit enter. And we end up in the default home page for the router. And as you can see, it's not really clear where port mapping would be on this network, or on this web page. They kind of buried it. So I'll show you where it is. It's under security. And then even still deeper, you have to click on the apps and gaming tab. And even still deeper, the single port forwarding link right here. And then you'll see the space where you will create your rules for your port forwarding. So according to our diagram here, well, let's start with the outside port, the port 80 to the web server on the Raspberry Pi, so 80 to 80. So the inside port's the same as the outside port, going to 192.168.1.123. We'll do that. Start with that. So the application name, this is just a label. You could call it whatever you wanted to. I'm just going to call it web server. And the external port is the outside port, of course. The internal port is the port that you're sharing out. In this case, it's the one on the Raspberry Pi, which is also 80. And here you have protocol. Now, if you don't know which protocol you're using, TCP or UDP, use them both. One of them will have to work, right? I know it's TCP, so I'm going to choose TCP. The IP address of the device, if we look down on the diagram, you'll see it's 192.168.1.123. So that's where we're going. And so 1.123. And then you have the option automatically checked off, enabled. We want that. And we're going to hit save. Okay, so there's the rundown on that rule. It's done. It's ready. It's going to go. I'm not going to hit apply yet because we have three more rules to put in. So let's add another one. And the next one's going to be the Kodi Media Server Remote on port 8080. And it's going through the router and out through the LAN port on 9090. So that's a little different, right? So let's do that. Again, just Kodi. Let's call it Kodi Remote, because that's what it is. And again, that's just a label. You can call it whatever you want. It won't make any difference. So the external port in this case is going to be 9090. There we go. And the internal port is going to be 8080. And I know it's TCP, so I'm going to keep it on TCP. And here, again, 192.168.1.123, because that's where it's at. It's on the Raspberry Pi. So here we hit save, and we've got our second rule in there. Add another one. And the third one's going to be the SSH. Again, reference the on 192.168.1.123, the Raspberry server. And it's straight through to 22 on the outside. So let's do that. SSH. And that's the command line connection to the, okay, so, and it's on 22 to the Raspberry Pi. So it's on 22. We'll go to the internal port, again, 22. It's TCP, I know, so I'll choose it. Again, if you don't know, then use both, and one of them will have to work. So 1.123. And here we'll hit save again. So SSH on port 22, straight through from the Raspberry Pi. Now we have the last one which we need to do, which is the camera. And if you look at the diagram, it is on 192.168.1.110, port 8080, and we're going to fish it straight through that router on 8080 as well. So it's straightforward line. So here we'll just say IP webcam, and that IP webcam is actually my Samsung Note 4 running an app from the Android store, from the Google Play Store, called IP webcam. Pretty neat, works well. You'll see it running here in a minute. So it's on 8080 on the outside and 8080 on the inside, and it's free, by the way. So pretty neat use of my smartphone. It's now an IP webcam. My old smartphone. I have a Note 8 now, which is also an old phone by most people's standards. So here we're going to go to 192.168. Oops, sorry. It's going to be on 1.110. Sorry, autopilot, I guess. So yeah, here we go. See, there it is. 8080 on the inside, 8080 on the outside, 192.168.1.110. So here we're going to hit save again. All of them are saved. And we're going to hit apply, which makes them active. Then we're going to hit OK. So the next thing we're going to do is connect to all these different devices, and I'll show you that next. Now that we've got our port forwarding rules all set up inside the router, the next thing to verify is to make sure that these devices on the inside of your network are running and the ports are accepting connections on the inside. Just to verify that everything on the inside of your network is doing exactly what it should, so that you can see whether it's working on the outside afterwards. But when you verify that everything on the inside is working, then you'll know that the problem, if you can't connect to it from the outside, is something in your router or to do with your router configuration. As you know that all the ports on the inside are accepting connections. But if they weren't, what would happen is that when you went out to the outside, let's say port 80 for the web browser, the web server on the Raspberry Pi, you go and connect to it, and boom, you don't get anything, any result out of it. You don't know why that is. You would say, well, gee, it could be the web server, or gee, it could be my rules aren't right in the router. But if you verify that everything on the inside is working, then you know that it's something in your configuration of the router. So let's verify all these things first. So the first thing you need to verify is that you're logged into the router internally. For me, it's I'm connected through Wi-Fi. You may be connected through a LAN cable or a network cable. Make sure it's connected to one of the LAN ports. And in my case, I'm connected through Wi-Fi onto that router. And I can verify that here with my IP addresses being 192.168.1.140. And the DNS server is 1.1, which is the inside IP address of that router. So I'm connected internally to that router. So here, we're going to test first the web server port 80. And the way you do that is to open up a browser window. I'm going to do that here. And go to the Raspberry Pi internally, which is 1.1.123. So it's 192.168.1.123. That's the router. It's on port 80. Now, because it's a web server, which is everything that your browser actually looks at as web servers most of the time, you don't have to put port 80 in there. The web server does it automatically. The web browser does that automatically. But I'm putting it in there just to show you that it'll happen, and the browser will probably strip it out. And it does. There's my web server running. As you can see, it's changed the IP address on the browser to 192.168.0.10 because that's the outside interface that it's programmed to listen to. So regardless, it's up and running. There it is. So the next thing we're going to do is, if you look at our diagram here, we've got the Kodi remote control on 8080. But I need to turn that on first. So we're going to test SSH port 22 first. And so I'm going to open up my SSH client or command line client, which is called PuTTY, and we're going to log into that Raspberry Pi internally on 123. And port 22 is already designated here on the session. So let's go and open it up. and bang, it's asking me to log in. So obviously port 22 is working. So I'm going to log into it and turn on Kodi, which is my media server on that Raspberry Pi. And right now, just by typing that in, it's running. So we're going to minimize this out of the way. And I'm going to have to reconnect to this and do this again on the outside. But regardless, that tests support. So we're going to go test. We just tested 22, no problem. Let's go test the Kodi remote control server. And it's 192.168.1.123. This time, it's 8080 as support. And the browser wouldn't do that for you automatically. So you need to specify :8080 to get there. And as you can see, there's my remote control for the Kodi media server. Perfect, running. And last but not least, we got to go test the webcam. And it's on a different IP address altogether. It is on 1.1. Oops, 1.110. So it's on 110 at 8080. So once again, all we need to do here is just change this from 123 to 110, :8080 again. And there's the remote control for the IP webcam. This is a free program I downloaded off the Google Store, Google Play Store on my Android device, which is a Note 4 Samsung smartphone. So basically IP webcam is free download on the Play Store, and any Android device with Wi-Fi and a decent camera can serve as an IP webcam. And that's what I'm using, my Note 4, which is now an old phone. And I've replaced it with a Note 8, which is also an old phone at this point. So here I'm just going to look at the video by putting /video, and there's my backyard. Nice sunny afternoon in Texas. And yeah, there's the IP webcam working just as it should. 1080p, free on my Note 4. Amazing, right? So I may do a video on IP webcam too, but there it is, running perfectly. So we verified that all our inside ports are currently working. So the next thing we need to do is close all this off. And yes, I'm going to close the session. And go and verify the outside. So the way we verify the outside on my system is I'm going to log into this router, which is connected to the WAN port on this router. And then from this network, I'm going to connect to those outside ports on that router. So we're going to do that next. Let's go back to our original. We'll start with the web server because it's up and running. We know that. So let's connect to it. So I'm going to connect to my, okay, there it is. I'm going to connect to my Wi-Fi on my Archer. There we go. Connect. There we go. And now I'm on the outside. So now I'll open up a browser. And we're going to go to 192. Everything will be on the same IP address. .168.0.10. And that's going to be on... and I'm just putting the colon in here. I don't have to. It'll happen anyway, even if I just put just the IP address again, because it's a web server. Up it is. There's my web server running on that router. On that Raspberry Pi through that router. So port 80 works. Next thing we need to check is SSH again, because we need to turn Kodi back on this media remote. So let's do that. Now we're going to use the PuTTY again, but this time on a different IP, 0.10. Again, port 22, as you can see here. Open, bang, shows me to log in. And let's log into it. So obviously, port 22 is working. And here we're just going to start the Kodi media server. Boom, running. So now we can test that, and that should be on the 9090 port because we crossed it over in the configuration, right? So if you look here, you see that it's 8080 here, goes through, comes out the other side, 9090 on the outside. So let's do that. And so :9090, enter, and there's the Kodi media remote control running, the play, fast forward, rewind. Nothing's playing, that's okay. Just basically, if it comes up, we know we're on port 9090 and it's forwarded correctly to port 8080 on that IP address internally. So last thing to do is check the camera, and that is on 8080 on the same IP address. So let's do that. 8080. There's the controls for the camera, and I'm just going to / here to video because I like the way that works the best. Video. Enter. There's my backyard. A nice sunny day again in Texas. Afternoon, I should have to say. And yeah, looking great. Looks like spring's coming. This tree's budding. You can see that's starting to get green. The one in the background, not the one with the bird's nest in it anyway. But regardless, there we are. All those forwards are working and tested perfectly. Okay, so you know, that's how you port forward on the Linksys EA8300. Again, links for all this stuff in the video description below. I really like the Linksys router, especially this EA. Seems to work really nicely. If you liked this video and it helped you out in some way, do me a huge favor and give me a big thumbs up on the like button below this video. Also, at the end of this video, you'll see a picture of me. That is a subscription link. If you click on that link, you'll be subscribed to my channel. As part of the process of subscribing to my channel, there'll be a bell icon. If you click on that icon, you'll be notified every time I put up a new video, and then you can watch it at your own leisure. Once again, and like always, thank you very much for watching and for your time.